Okay, let's say we're given a graph and you're being asked to find all critical points. And determine the nature the type of critical point by the second derivative test. Yes?
Is that just a positive sign in front of the x squared, the e to the positive x squared?
No, this is a minus here.
No, the other x squared.
This one's, no, this is a 1 minus.
Oh, okay,
Alright, so let's try this one. So first, to find the critical point, what do you do? Set what equal to 0? Gradient equal to 0. So you have to compute the gradient first. So let's find the gradient. Gradient of this function, let's call this f. That's, if I differentiate by x, I get, well, this is a function of x, and that's also a function of x. So when we differentiate this, we have to use the product rule. So let's use the product rule. Negative x squared differentiates to negative 2x. When I'm differentiating this stays unchanged. That's what the product rule says, right? And then you keep it unchanged while differentiating the other one that you didn't differentiate. And when you differentiate this, you have to use the chain rule. What does the chain rule say? I have to multiply by the derivative of the inside function. The inside function is this. What's that? Huh? We are differentiating by x right now. Yeah, I'm doing product rule. What was it? Negative 2. We're differentiating by x, I said. So this everything I wrote here is just the derivative of x. Okay. Now I have to differentiate by y. Again, it's this is a function of y, and that's also a function of y. That means you have to use the product rule first, which gives you 2y e to the 1 minus x squared minus y squared, and then plus 1/2 negative x squared plus y squared e to the 1 minus x squared minus y squared times, this time what do you put in? Negative 2y. Okay. That's the gradient, and I need to set this equal to 0, meaning that each component has to be 0. Alright. It looks really hard, but thankfully, this thing here is a common factor between the two, right? So I can factor that out. So fx is e to the 1 minus x squared minus y squared. And then the first thing gives you negative 2x. And second thing, 1/2 times negative 2x is negative x. And then negative 2x times negative x squared is positive 2x cubed. Y squared times negative 2x is negative 2x y squared. That has to equal to 0. That's f of x. Let's do the same for fy. E to the 1 minus x squared minus y squared can be factored. And when you factor it out, you have 2y minus y, and then plus 2x cubed, and then minus 2y cubed. Sorry, it's 2x squared y, and minus 2y cubed. So, by the way, I'm writing these things down because sooner or later we'll have to differentiate fx and fy, right? And let's see. We should simplify as much as possible because we want to differentiate the simplified one. The more simplified it is, it's easier to differentiate. So let's simplify. So we have f of x. These two can be combined, right? So we have negative 3x. But then you see that x is everywhere, right? So I can pull the x out. This is what you get. It's times x. What you're left with is negative 3 plus 2x squared, and then minus 2y squared. Then fy is equal to 1 minus x squared minus y squared times x. This time it's times y, right? Because y is the common factor. 2y minus y is just a single y, so when you pull the y out, you left it with a 1 plus 2x squared minus 2y squared. Yes? Okay. Alright, and now in order to get the critical numbers, I need this to be 0 and this to be 0. I need both of them to be 0 for a pair of numbers x and y to be a critical number. Alright, let's see. Start with the first one. X equal x times negative 3 plus 2x squared minus 2y squared is equal to 0. In that case, we have two possibilities. Either x is 0 or negative 3 plus 2x squared minus 2y squared 0. In which case, you can move that negative 3 and 2y squared to the other side and say 2x squared is 2y squared plus 3. And the system, oh, by the way, why did I leave this one out? E. Because it's never 0, right? So exponential functions can never be 0. The only way that this entire thing can be 0 is when this time this is equal to 0. So that's why I just wrote that down. So I have this. So what we have is a system of equations, this one and that one. And I know that a lot of you didn't have much experience solving lots and lots of system of equations, especially when it's not a linear equation. But it's not that hard. Always the way you solve it is you solve the first equation for one of the variables and you plug it into the next one. That's how things work. Okay? So that's what we're doing. I'm solving the first equation for one of the variables and you plug into the next one. So for each of these cases, we have to track what's going to happen. So if x is equal to 0, what happens if I plug this into the second one? What happens? Y times 1 minus 2y squared is equal to 0. Right? Because if I plug in x equal to 0, you get y times 1 minus 2y squared equal to 0. Isn't that right? Okay. Therefore, either y is equal to 0 or 1 minus 2y squared is equal to 0. Which is the case when if I move the 2y squared to the other side, I get 1 equals to 2y squared. And then, okay, it's a lot of work. Y squared is 1/2, and you take the square root, it's 1 over square root of 2, plus or minus. Remember, whenever you take the square root of something, you have to put plus or minus. So we have the following 3 points. We have, what 3 points that we found? Did we find? 0, 0. So x is 0, right? So either 0, 0, and then
0, 1 over at 2.
0, yeah, 0 comma 1 over square root of 2, and 0 comma negative 1 over 8. But that's just one part of the story. We still have to track down this one. Now I could have solved further for x and then plugged into the next one, but I stopped here because I saw that there's already 2x squared, so if I replace 2x squared by this, that gets rid of the entire thing there, right? So in that case, so this case here would lead to y times 1 plus 2y squared plus 3 minus 2y squared equal to 0, because I can replace 2x squared by this. And these two cancel and you get 4y, so you get y equals to 0. 4y equals to 0, so you get y equals to 0. Oh, okay, so if y is equal to 0, I can plug that back in here to get the x value. So what is x? 2x squared is 3. So x squared is 3 over 2. So you get to do the square root of plus minus square root of 3 over 2. All right, so it was actually quite a long question. But this is what we found so far. We found the critical numbers to be 0, 0, 0, comma, plus or minus square root of 1/2, and 0, comma, plus or minus square root of 3 over 2. That's what we found. How many points in total? 5 points. There are 5 critical points for this, okay? Plus and minus counting for each individual points, okay? All right, now we have to calculate the Hessian. That means we have to differentiate this. All right. It's not what I would like to do, but I guess I have to do it. So Hessian is h of f means fxx, so we have to differentiate this by x. And this time it's a function of 3 variables, right? Three functions of, it's a function of 3 functions. It's made up of product of 3 functions. So I have to use product rule for 3 functions. Do you know the product rule for 3 functions? Differentiate the first times the second and third, plus first times the derivative of the second times the third, and then last one is plus the first and second unchanged, and then the last one is differentiated. So we're going to use that. Let's do that. So it's if I differentiate the first, it's the second and the third is unchanged. And then plus if I differentiate the middle one, it's just 1. Okay, and then the last one I have to differentiate, which is each the 1 minus x squared minus y squared times x times the derivative of the last one is 4x. So that's what I get if I differentiate f of x by x. Let's simplify. It's each the 1 minus x squared minus y squared. And then, let's see, these are same, aren't they? I guess it's better just to multiply everything out. I should have just multiplied it out before differentiating. Negative 2x squared times negative 3, so that's 6x squared. Negative 2x squared times plus 2x squared, so it's minus 4x to the 4th. And then plus 4x squared y squared. That's what I get by multiplying everything out here. And then minus 3 plus 2x squared minus 2y squared. And the last one is plus 4x squared. That, and then to simplify further, combine the like terms. So you have minus 6x squared plus 2x squared plus 4x squared. That's 12x squared, right? 12x squared, and then x to the fourth, you just have minus x, 4x to the fourth, and plus 4x squared y squared, and then minus 3 minus 2y squared. All right. Okay, what about fxy? This time it's a product of this function of x, y, and function of y, so you can differentiate this again by y. And we're out of time here. Okay. I thought I could finish this, but it's out of time, so.
This question being touched.
Huh?
Something was hard.
I mean, this is a homework question, so. All right, so try this on your own, okay? Plug in values.
Even a little.